So here we go. We're going to solve this system of equations. And I want to solve the same system, and I want to use two different methods. So the first method is the first one that we learned in class, which is graphing. And I'm not sure if that's the best method for this system of equations, but we're going to do it anyway. The reason I don't know if it's the best method is because both of these are in standard form. And equations that are written in standard form can be a pain to graph. So I'm going to do what we normally do, which is I'm going to convert them to slope-intercept form. So I'm going to start with this first equation, which this is x minus y equals negative 5. I'm just copying it down here so I have a little bit of room to work. So I'm going to the first thing we should always do is move the x term to the other side. I think that's a really good way to start. And then don't forget that this minus sign in front of the y, that sticks with the y. So that's what's left over here is this negative y. And on the other side, I have negative x minus 5. But I don't like this negative y because we're not in slope-intercept form until we have solved for y. So we're going to divide everything by negative 1. And don't forget, you need to divide the whole equation by negative 1. Both terms on this right-hand side. Not just the x, not just the negative 5, but everything. And so what I have here is y equals x minus 5. Or I'm sorry, x plus 5. Because a negative divided by a negative is a positive. Now that's easy enough to graph. It starts right here at 5. And then it just goes up 1 over 1. And I'm just going to make dots. Because I'm looking for a common solution. So here we go. We've got some dots there. And I'll make some back here. And if I wanted, I could make a line that would go through all those dots. But I think that'll work out just fine. Now I'll switch colors here. And then we'll do this other equation, which is 2x minus 3y equals negative 18. And I have to repeat these same steps. So I'm going to start by moving the x term. I'm going to subtract 2x from each side. So then I'm going to have negative 3y equals negative 2x minus 18. But now I have to isolate that y. So I'm going to divide every single term by that same negative 3. And now I have y equals, remember, a negative divided by a negative is a positive. So the slope, it turns out, is a positive, and I'll just leave it as a fraction. It's 2/3 x. And then negative 18 divided by negative 3 is a positive 6, so I write plus 6. So now, easy enough to graph, right? You know we start at 6 on the y-axis, and then we were supposed to go up 2 over 3. Oh, I found my solution. Isn't that cool? The common solution was easy enough to find. It's right here. And so the solution that we're looking for is 3, 8. That is the solution. So that's one way to solve a system of equations. You can graph any linear equation as long as you can convert it to slope-intercept form. It's easy enough to graph. But I know what you're asking yourself. Could we solve this without graphing? The answer, my friends, is yes, we could. So we're going to do this. Instead, we're going to use the substitution method to solve this. And in order to substitute, you have to solve for one variable in terms of the other ones. Now, we have already done this. We could just use the work that I've already done up here, right? I solve for y here. I know that y equals x plus 5. So that's already done. I could use that down here. I could also, if I really wanted to, I could use y equals 2/3 x plus 6, and I could substitute that into one of these equations. But I don't know if either of those would be the way that I'd go with this particular system if I hadn't started yet. In fact, I think the easiest way is to use this first equation, equation 1, and to isolate this variable x, because it's just one simple little step. So I'm going to pretend that I hadn't done all that work, and I'm going to say if x minus y equals negative 5, and I want to isolate x, I can just add y to each side. That turns out that x equals negative 5 plus y. And that's a thing, right? That's what x equals. So I can use that. Any place I see the letter x, I can use that. Instead, I can use negative 5 plus y. What you don't want to do is use it in the same equation that we just solved for. Instead, we should use it in equation 2. So this letter x here, it's this little x right here that's next to the 2, I'm going to replace it with this bit, this negative 5 plus y. So here, I'll just rewrite that equation. 2x minus 3y equals negative 18, like so. But remember, this x is the thing that I want to replace. So I'll write the equation again. I'll write 2, and I'm going to leave a big space, and then I'm going to write minus 3y equals negative 18. The reason I left that space is because I need to substitute. Instead of x, I'm going to use this other thing that x is also equal to, which is negative 5 plus y. Let's make that nice and dark. There we go. Now, look, I have an equation. I have a single equation, this one right here. And that single equation has one letter in it, the letter y. And no matter what level of mathematics you're at, one thing you should always know is if you have a single equation and there's just one unknown letter, there's always a way to figure out what that letter is, unless there's other complications. But in our case, there's definitely a way. Well, the first thing I'm going to do to solve this is to just use the distributive property to eliminate the parentheses. So I get negative 10 plus 2y minus 3y equals negative 18. I just rewrote the rest of the equation. Good. And the next thing I should do is combine these two terms because they are like terms. That's a positive 2 and a negative 3. So that's negative 1. And so I have negative 10 minus y equals negative 18. And I'll just continue to solve, and I'll get through this really fast. So adding 10, I have, negative y equals negative 8. And of course, the y is not done yet, but I should divide by negative 1. Okay. And there we go. Y equals 8. Remember, that's what I got up here. Right here it says y equals 8, right? And I know that x also equals 3. That was what I found when I graphed it. But I'm not done with my work if I'm solving using substitution until I've also figured out what x equals. Right? Y equals 8 is great, but I'm not done. I must have a ton more work to do because now I have to take this 8 and figure it out. Oh, wait a minute. No. It says right here that x equals negative 5 plus y. You're telling me that negative 5 plus 8 equals 3? Yes. So we got the same solution using two different methods.